Hello everyone, welcome to our lesson today on the tangent ratio. Let's hop right into it, right? So first and foremost, tangent only works for right triangles, right? So whenever you see something like this, right, this indicates a 90-degree triangle, which means it's a right triangle. This is the only place where we can use tangent or, in fact, any of the trigonometry ratios. Right? So tangent, in a nutshell, tells us the ratio between the opposite side of an angle to the adjacent side of an angle. Right? So in this case, right, in our first example right here, our first drawing here, right, we are looking through the angle A. Right? So whenever we work with trigonometry ratios, so things like tangent, we always have an angle that we refer to. So in this case, we're referring to this angle right here. We call it angle A because it is at point A of a triangle. So in this case, using angle A, tangent A is the length of the side opposite to angle A over, right, or as a fraction, over the length of the adjacent side. Right? So in this case, the length of the side opposite to the angle A, so it's this side right here, over the length of the side adjacent to the angle A, so it's this side right there. Right? So that's pretty much all it is. All we are saying is we pick an angle, we are taking the length of the side opposite to it over the side that is adjacent to or connected to the angle. So it's pretty much a simple division. Right? So let's go over some examples here. Right? Or I guess I should note, only, in all caps, only for right triangles. Right, so let's get a highlighter here, right? We know it's a right triangle. Right, so we know something is a right triangle if we see this little, the color doesn't really show here. If we see this little square here, right? That indicates a right triangle, right? And now as you can see in the second triangle down here, tangent is usually expressed as a decimal. And once again, since this is a ratio, all we are saying is that this side right here is 1.5 times longer than this side. Right? So again, it's the opposite over the adjacent. So in this case, we have the opposite side right here. This side is 1.5 times longer than the adjacent side. Right? So if it's a bigger number over a smaller number, then we get more than 1. If it's a smaller number over a bigger number, then we have less than 1. Right, so let's draw some examples here. Right, so those are some pretty common questions you will encounter throughout this chapter. Right, so first example, determine tangent D and tangent F. So in this case, tangent D, okay, let's get our highlighter here. Tangent D will refer to this right here. Right, so we're looking at this angle right here. And as we can see from this angle D here, 3 is opposite to this angle, while 4 is adjacent or right next to this angle, which means that the tangent of D is just 3 over 4. Right? So as a decimal, it's 0.75, which means that the opposite side, so this side right here, the line FE, this is 0.75 times the length of DE. So now, similarly, if we look at tangent of F here, right? So we're looking at this angle now. The tangent of F would be, as you can see, the opposite is 4 now. Look at this angle. The opposite is 4, and the adjacent is 3. Okay, so we have 4 over 3 instead, giving us 1.3 with repeating. So in all cases of trigonometry, all your answers will depend on the angle you're referring to, right? As you can see here, the angle D and angle F give us completely different answers, even though the concept of tangent is the same. Right, so now the ratio is very useful, but what's even more useful is finding out the exact angle. Right, so let's take the next question, for example. We're looking at the angles of J and G. Right, so once again, we'll color code it once again. G refers to this one, the angle J refers to this one. Right, now we actually want the individual angles of those two. Right? So once again, we'll use tangent. So again, the tangent of G Right? As we can see, the opposite is 4. The adjacent is 5. So the tangent of g is 4 over 5. Right? So again, this gives us 0.8. But we're not done yet here. 0.8 is just a ratio. It is not an angle. Right? A common mistake I see is that on the answer or on a test, you have 0.8 degrees. But you're not done yet. So this is a ratio. So now what we have to do is in our calculator, you should see a function called tan inverse. Right? So on your calculator, you're looking for a button that looks like this. Right? Tangent inverse right here. And now with most people, it should be right above your tangent button. Right? So for most people, we should have a tangent button on the calculator. And above the tangent, usually in yellow or orange, we have tan minus 1. So we want to get to tan minus 1. This is the function we want. So on your calculator, you just press second, right, or your function key. You press the second function, and you press the tan key. Right? That will get us to the tan inverse on your calculator. Right? So just a heads up, tan inverse, it's pretty much impossible to do it by hand, so you're allowed to use the calculator for this section. Right? So from here, we just do the tan inverse of 0.8. Right? If we punch that into a calculator, so tan inverse 0.8, we get 38.66 degrees, but the action or the question wanted us to be the nearest degree, so we round this to 39 degrees. Right? So we're essentially converting the ratio into an actual degree or an actual angle that we can actually conceptualize. Right? Some of you may get the answer of 0.67. Right? This right here, unfortunately, is incorrect. Right? This is radians. This is a very common mistake again. Make sure your calculator is in degrees mode, not radians mode. Again, in most calculators, you should have a button that can convert between the two. Right? So now let's try the next one, j. Right? So the tangent of j, we know, as we can see here, opposite is 5, adjacent is 4. Just 5 over 4, which comes out to 1.25. And now we do the same thing once again. Right? Inverse tangent, but instead of putting the decimal, we should just keep it as a fraction. Right? Most of the time, you won't get a really pretty decimal. It's going to be a really disgusting and long decimal. So chances are it's most likely easier to put as a fraction in your calculator. So the tangent of 5 over 4 gets us 51 degrees. Once again, making sure it's in degrees. And just to quickly double check, do those answers make sense? I will say yes. Right? We know the angle G right here. Angle G is 39 degrees. Angle J is 51 degrees, even though they don't look like it. And remember, the triangle is 180 degrees. So if we add all the degrees up, so we have 39 plus 51 degrees plus a 90 degrees, as we know from here, this will get us exactly 180 degrees. Right? So those two answers make sense. A quick way to check your answers is to make sure all the angles you find add up to 180. Alright, so now moving on to a word problem here. A bird watcher sees an eagle on top of a 20 meters tall tree. Okay, so let's draw it out. So this tree right here is 20 meters tall. Okay, of course, we got a little eagle here. Okay. And now the bird watcher is standing 50 meters from the tree. So we have the bird watcher right here. They're 50 meters away from the tree. And now we're asking, if they want to take a picture of the eagle, what angle do they have to incline their camera? So all we're asking for is, what is this angle right here? Right, at what angle can they aim their camera at to look at the eagle? All right, so this is pretty much looking at a triangle like this. All right, where this is 20 meters, this is 50 meters, a right angle right here, and we're looking at the angle right there. Right? So in order to do that, let's just say the angle B for birdwatcher. Right? To find this, we just take the tangent of V, which is, right, the opposite in this case will be 20. The adjacent is 50. Right? So the tangent of B is just 20 over 50. And when we plug into a calculator, so the inverse tangent of 20 over 50 is 22 degrees. Means that as a photographer, you have to incline your camera up at 22 degrees in order to take a picture of the bald eagle. Right? So that's a pretty practical way to use tangents. And with that being said, right, here's some practice questions. So pause the video here and try to do them yourselves before we go through them together. Alright, hope you got some time to practice this, and let's go through them quickly. Alright, so for the first question here, we want the tangent ratio of each acute angle. And of course, we have both of them right here, C and A, and K and M. Like all those angles are acute because they are less than 90 degrees. So now all we have to do is, again, looking at the question here, we do not need the angle yet, we just need the ratio. Alright, so looking at tangent of A, opposite of adjacent is 6 over 7. For angle C, that'll be 7 over 6. Looking at angle K now, will be 5 over 7. And then angle M, that'll be 7 over 5. Alright, so again, same principle. Like again, for M right here, the opposite is 7, the adjacent is 5. So we have 7 on top, 5 at the bottom. Alright, that's an easy. So now the next question, we'll actually need to use our, so now for the next question, we actually have to calculate the degree. Right, so there are two indicated angles we have to look at. So the first one is right here. This is the angle we're looking at. And so in order to do the inverse tangent, right, we take the opposite over the adjacent. So opposite in this case to this angle is 3. The adjacent is 6. Plug it into a calculator, which again, hopefully in degree mode, gets us 26, or no, 27 degrees because we round up. All right, and the next question, we have, once again, a mysterious angle here. The opposite is this one, the adjacent is this one. Something interesting here. 14 over 14, we know that is just 1. Right, the inverse tangent of 1. To be honest, this is one of those questions which we probably don't need a calculator for. But if you get a right triangle with equal side length, we just have 45 degrees. Right, if the right triangle has equal side length, we have 45 degrees here, 45 degrees here, and a 90 degree right there. Right? Yeah, but the principle is the same, whether it's the same side length or not. You have the opposite over the no, that's later. You have the opposite over the adjacent, and then you inverse tangent it. Alright, now an interesting word problem. The angle of inclination is the angle between the slope and the horizontal. So in this question, it's this angle right here. Right, so this is the angle of inclination. Horizontal, slope, right there, that's angle of inclination. The question is asking for the angle of inclination for the solar panel. So we are almost given enough information. Right? We just have to find out what is the length right here. Because if we just do tangent, or if we did the inverse tangent of 5 over 4.2, right, so inverse tangent of 5 over 4.2, we get 0.02 degrees, which very much not to scale, but this will be the angle right here. All right, but in this case, we want the angle, oops, not the ruler, right here. So in order to find that, we have to subtract the 7 from the 4.2 to get 2.8 meters. Right, we have to find the length right here first. And now we can use tangent again. Right? So, just zoom out a little bit. The inverse tangent of, in this case, the opposite is the 5. The adjacent is a 2.8. Once again, not 4.2. That's the wrong angle here. Opposite is 5. Adjacent is 2.8. Over 2.8. this will get us 60.8 degrees. And to the nearest degree, correct? Oh, I did not say, but let's just leave it to the nearest degree. So the nearest degree will be 61 degrees. Right? And that's the answer. Right? So it is very, very enticing to just have inverse tangent, number 1, number 2. Put those numbers together, inverse tangent. But you have to really read the questions carefully. Yeah, with that being said, that's the end of the lesson today. And that's about it. So keep practicing and stay hydrated.